Welcome to the Practical Data Lunch and Learn. Today we have a special guest, my friend Jaime Villalpando. So he is going to talk about data modeling, but probably not in the way you've thought. We're going to talk about Kimball, when it's great, when it's not enough. And so from there, I'll let you kick things off.
Okay, so hi folks, as Joe said, I'm Jaime Villalpando. Pretty excited to be here to share a few things I've learned along the way. So a little bit about myself for those who don't know me. I have a bachelor's degree in computer science and a master's in data science. I started my career focused on software development. That's what I wanted to do. But I fairly quickly realized that my true passion was in data. And I was very interested in helping. I've always been interested in helping organizations make better decisions using data. So I've been doing that for the last 15 years. I've been working on data engineering and analytics. And currently I work at Apple as I manage a team of data engineers and analytics engineers. And prior to that, I worked at Microsoft as a data engineer in a data team that covered a couple of services, cloud services. So with that, let's talk about the agenda. What are we talking today? So today is a practical demonstration of the data modeling approach I prefer, and that's sort of learned along the way. The goals I have is to share this, get feedback, learn from others. I think, as many of you, I'm always interested in trying to find better ways of doing things. I'm also interested in, particularly in this case, it's worked quite well for the use cases I've been exposed to, but I wonder in which cases this applies, or this is not the ideal solution or the ideal approach. So I'm interested in learning that. I want to encourage others to do the same. To me, like, data modeling is what the main factor that determines, or the most important aspect that determines outcomes for data teams. And I still see, unfortunately, a lot of teams either not prioritize it accordingly or not follow the right practices. And this has ripple effects to everything they do. So I'm interested in this is why I joined the practical data modeling community, and I'm interested in working together to sort of elevate data modeling practices and learn from each other. So with that, let me talk a little bit as an introduction to the specific approach. And there's many, as Joe has highlighted, there's many sort of modeling areas. But this specifically is focused on analytical data modeling only and batch. So batches, because the business can make decisions based on data that is 24-hour or 48 hours old. A requirement as well, and ideal for me when I'm looking for an approach in this space, is something that has no theoretical limit because of how much data we can handle, because you don't want to have to outgrow your approach. Data modeling is something that you have to prioritize and do constantly. And while the tooling around it and some of the techniques might change, the approach itself shouldn't change. You should be able to go with it. So that's important to me. The other point is, as much as I love relational data warehouses and databases, those should be optional, not required. And that is because of flexibility. We want to have flexibility in the architectures we choose and the different tools we choose. And being forced to do that, in Kimball, for example, you have to use surrogate keys. And in order to do surrogate keys, you need identity or auto-increment columns. I don't want to have to depend on this, and I want to have flexibility. So this is important to me. And finally, because of this, I think a requirement is having a data lake at least at the ingest layer. You could do whatever you want afterwards, but this gives you a couple of benefits. One, of course, you can handle any data volume. But two, you don't have to structure data when you ingest it. You can just ingest the data as any type of data, and then do processing afterwards. I think that paradigm is really powerful. So the goal of doing this is this type of approach is to democratize data access to as many users as possible, make it available in SQL, data frame APIs if possible, definitely reports, and definitely BI dashboards, so that as many people as possible in the organization can use data. I would describe the modeling approach that I'm going to talk about as, I don't really have a name for it, but I would describe it with these 4 words, which is dimensional, it's denormalized, it's functional, and it's idempotent. And this is inspired by Kimball, but adapted to modern needs. I would say the simplest way to describing those needs is lots of data, or having the capacity to handle lots of data. So with that out of the way, I've created this use case so we can walk through and go over sort of a series of go over the data modeling approach. So let's start with what is going to be the use case. This is going to be, imagine we're a cloud storage service for enterprises. Imagine something like Box, and in Box we have it's a cloud storage service where organizations and businesses can upload, and users in them can upload a lot of files and manage them. We're going to be focused on user engagement, on churn, and on business health. And some basic concepts before we get started with modeling itself. Tenant, this is a multi-tenant service. Tenants are the organizations of companies that get the service. They are the ones that have to pay for this. Subscriptions, it's a subscription model, and you can have one or more subscriptions. They could be billed monthly, yearly, they could be free. You could select, you could have a use case where like 100 users have this type of subscription, but 10 power users have a different, more expensive one. You can mix and match. User, here in the context of this use case, every user is tied to a single tenant and one tenant only. So if you have a user ID, you can figure out the tenant ID. File is the basic building blocks of the service. You store files. And endpoints is the different clients in which you can access the service. It could be the browser. It could be the iOS app. It could be the Android app. It could be the Windows. It could be the Mac OS. Whatever the different clients we have available, I would refer to them as endpoints. And before we get started, so that we can distill the essence of the approach and we can go over the important points, I'm going to simplify time. I'm going to assume that ingestion time is the same as event time. Or
quick question. Are you presenting any slides right now? People
Yes, I am.
Oh, they say the slides aren't moved. Okay, there we go. Okay, perfect.
Are they not moving at all?
I see one that says use case. I saw one that says introduction, then use case right there. And so, and it still looks like it's not in presentation mode.
Let me check. Oh, thank you for stopping me. Well, I see.
Thanks for pointing that out, Alex and Zog.
Well, let's see. This is weird. Can you see this in presentation mode?
I can see. Well, it didn't go to presentation mode. It just says use case right now. But other people might be able to. So I don't know.
This is actually a little bit okay.
Okay.
Let me see how I can do this. Present something else.
Showing across two screens. You might have your speaker notes being shared.
Or let's see. Stop presenting. Sorry, thank you for highlighting this. Window. Let's see. I guess I can do it out. It is important to share. Sorry about this. Let's try again. So let's see if this works. Let's see. Oh. Can you see that now?
Yeah, there we go. Yeah.
Okay, perfect. Thank you.
Cool.
Okay.
Right.
So I don't know how much you saw, but hopefully what I talked about made sense. This is as far as I got. Okay, good. Now I actually can see it on the side. Okay, good. So with this, let's actually start the modeling exercise. So yeah, here it is. So when we get started, let's assume we're 3 months from launching the service, and we start talking to the business, and everybody's interested in, as it's always the case, they want to know everything. But hey, we're 3 months from launching the service. We need to focus on something. So we talk to the business, and they distill, you know what? Engagement and usage and churn is what really matters. So let's just get usage data. So we're going to start with event logs. And with event logs, just a little bit of background here, we're going to use event logs to capture real user activity. So things like we're going to have an event for like file created, file edited, file viewed, file shared, file deleted, and so forth. And then in addition to that, though, as is often the case in my experience, the engineering team is interested in some like diagnostics or things that it's done on behalf of the user or in background activities that they want to track. So we're going to let them do it in the event logs. We're just going to make sure that they categorize those as diagnostics. So every event It's going to have a category, to keep it simple, engagement when it's user initiated, or diagnostic when it's not. Okay, and we're going to have a bunch of different things like OS and tenant and user ID and a bunch of different things. And this is going to land in the data lake in whatever format. It doesn't really matter. So afterwards, we need to actually process this. And we're going to do the first thing. We're going to create a table called events. And a couple of important things here. We're going to do this incrementally. We're going to process every day. So we're going to partition by ingestion date. The conceptual grain of this is event time, user ID, and event. But of course, I mean, this isn't enforced. At this scale, we can't enforce it, but still, it's important to call it out. I'm going to be calling it out in all the tables we generate. Then you can imagine there's going to be a bunch of different columns, like I mentioned, OS. There might be like the category, the tenant ID, properties, so that every event has a property bag that can describe different properties that every single event that is different across events. And then finally, as a rough, this is a guesstimate, but especially when you start, but roughly every day we're going to have 100 million rows here. And after 3 years or so, we expect to get 100 billion plus, just to get a little bit of the size of this. So there's a couple of things I want to highlight at this step already. That one, it's functional and idempotent. We're already doing that. We're doing it in a way that every day we process the data that arrived for that ingestion date. And if I rerun a job 5 times, it's always going to generate the same result. It's going to be idempotent. It's going to overwrite. Before it writes down, it's going to overwrite the ingestion date partition and write everything else on top of it. The other thing that I want to highlight this early on is natural keys. And this is where we start diverging from Kimball. Kimball encourages us to do surrogate keys. We're not going to do it here. We're just going to use the natural keys, and we're going to use a UUID, let's say, for user ID and tenant. And those are already IDs that are enforced at the service level. So in any case, we're here. Great. And you could argue at this point, we are in a place where like the business can answer all the questions. Sure, this is a big table, but if they wanted to do active users, engagement, retention, they can do it from this table. But it's too big, and it's like, I think we could do better. We can make it a little bit more efficient and easier for consumers. So we're going to do our first aggregated fact table. And we're going to aggregate by ingestion date, by user ID, by event, and by endpoint. And now you're going to see 2 things happen. Oh, and we're going to group by those things, along with like things like tenant ID that is associated with a single user ID. So we'll put it in. And also category that doesn't really increase the grain or the number of rows. But then we're going to have proper things like number of events. We are going to aggregate and we have number of events. First event time, last event time, things of that nature, we can aggregate. Now, a couple of things happen here. Not only did the grain, like the number of rows go from 100 million a day to 20 million a day, that's great. But the events table is quite wide. And this one is just going to be maybe the ones that you see in the primary key, plus tenant ID, plus category, plus a few extra like aggregated measures like the first, last event time and number of events. But that's it. So I would argue that roughly you're going to get 10, maybe even 15x reduction in the storage footprint. So this already makes it quite useful for analysis. And this is very beneficial. But we could do more. So now let's do this. Now we're going to aggregate. Let's say we don't care about the endpoint anymore. We're just going to have ingestion date, user ID, and event. And what if we don't care about the event anymore? We just want the user ID. So every single day, every single user that is active, I want to know the information about them. And we can actually even extend it further. We could say by tenant. We can say for every single ingestion date and for every single tenant, I have a number of active users. So for example, and you can see the enormous difference between events and the aggregate usage by tenant table. So if I want to do daily active users, I query the aggregate usage by tenant table, I group by ingestion date, and I sum active users. And I have that. Great. Now, the business might come back and say, actually, I want MAU. I want monthly active users. Well, you can easily go to aggregate usage by user and do it from there because it's at the right grain. So there's a couple of things I want to highlight at this point. One is that Kimball did have aggregate fact tables, but he's recommended, I'm reading this, it says they should not be encountered directly by business users. We're not doing that. We are exposing this to analysts. Given the scale, with the scope, this is just a lot easier to, more performant, and you can also simplify your queries in many cases by having these aggregates. And these are simple aggregates. Most of these are like group bys or whatever. They could be more advanced, but so we're gonna do that. Now, another point here though is I did mention that this was dimensional, this part of the modeling approach, and there's no dimensions here. So you might think, oh, let's say we want to bring the user dimension. Then, well, we need to go and talk to the engineers to make sure they upload from the source system the user dimension. And we're going to do that, but not quite yet. We don't need it. We can actually already create a user dimension with the information we have here. We can do this. So, and this is also starts deviating more from Kimball. So let me tease this apart. What this table is for every single day, it's going to tell me as of that date, going all the way back in time, and for every single user that has been active, how many days they've been active. When was the first time they were active? The last time they were active? Things of that nature. And now I have a very powerful sort of usage-based dimension that even later when I bring the source system in, I'm not going to be able to have that information. No source system is going to have that. Now, this is a couple of things to tease apart here. One, we do this incrementally. The first time this runs, I just go to ag usage by user, aggregate the data, and get group by subject ID, and I get those measures, those facts there. But the next day, then let's say day 2, I will go to the day 2 aggregate usage by user, do the same aggregation, and then I will do a full join to the previous partition. And that way, incrementally, I keep creating this. Now, this dimension has a couple of issues in terms of as Kimball is concerned. One is that Kimball recommends SED, slowly changing dimensions to model them as a type 2. I never really considered any other type because that's the only type that you preserve all history. So, okay, so he recommends SED type 2. But you're going to find out that with this type of like modern architecture, doing a daily snapshot is easier on a number of fronts. One, if you're a user and you want to query this data, it's easier to do a unique equi join than to have to do a range join. It's a little bit simpler to write in SQL. Secondly, performance is actually going to be impacted if you have an SED type 2 table, because range joins are notoriously hard for distributed compute engines. So with the advent of cheap storage is the thing that is the cheapest. We want to try and, to an extent, conserve compute time, but also engineering time. You're going to find that daily snapshots are a much better approach, in my opinion. So that's one thing that we changed from Kimball. The second thing, though, is that Kimball was pretty adamant about sticking raw facts, keeping raw facts like in the fact tables, not putting them in dimensions. We are doing, for example, number of days active. We're putting it into this dim user dimension. And he was against that. He recommends banded attributes where you say, well, it should only be descriptors. So it should be between 0 and 30 active days, or between 31 and 60 days. And to me, that is incredibly limited. It made sense at the time, but with the current sort of landscape, I think this is a better approach. You can have the exact number of days active, and then you can slice and dice based on that. In any case, we're going to return a little bit to this, but we have this dimension already, but we can do more. We can do even more. So we could do something like this. What if we're interested in doing the same idea, but I want it by user and by event? Imagine an analyst has a question of, well, I want to look at all of the people who have shared files, and what was the first time they've shared them, and how many times have they shared files? You can easily do it on this too. So it's the same idea. It's just you aggregate it by user and by event. Now, a couple of things here worth highlighting is so far we've exposed all of the partitions. This is a case where, as a data model, like a designer, we could choose to say, this table, I'm only going to expose the last partition. Well, it's like a 50 billion row table. It's getting close to events. I want to make queries snappy. And also at the same time, most people are likely going to be interested and this is in general for these types of dimensions, most 80% of people are interested in the last day. So we don't have to expose the full history of that. And there's a couple of benefits to this, though. You can always, it's a reversible change. If it's actually in storage, it's actually available there. So you could choose to later on expose that data to across all the partitions. Furthermore, if you have storage considerations and you think you actually are not going to need that, one approach you could see, and I've seen us do that, is you could say, well, I'm just going to keep the last 30 days of partitions and then slowly delete older partitions. And this has the benefit of if there's a bug or something, you can always backfill up to the 30 days. But of course, sometimes bugs are found that, oh, actually, I needed to backfill further. And in that case, though, you have all of the events, or you have all of the aggregate events in this case, as it's based on that. So you can always redo it from scratch. So I don't think there's a lot of harm in doing that. One other thing I forgot about the DIM user dimension is that it's really powerful because you can do things like, I want to do a rolling DAO. So based on the last 7 days, I want to consider active users, those who did anything in the last 7 days. So you can go to DIM user, group by as of ingestion date, and check whether the last receipt or the last event time is greater than the difference between the last ingestion time and the current partition is up to 7 days apart. And you can do a count if or case and count only those. But then later on, somebody can come in and say, you know what? I actually don't want it. We changed the definition from 7 to 14 or to 28 days. You could easily change it without changing any of your model. So that's very powerful. Now, we could extend that paradigm that we use in DIM user by event to also DIM user by endpoint. Maybe I'm going to ignore the event, but I do want to know the endpoints. And this table is useful if I want to know how many people have more than X amount of endpoints and when was the last time they used them. And you can do a lot of really fancy analytics relatively easily with this. Now, at this point, we're great. We've kind of exhausted the event logs, but of course, we need more information. So, and before we do that, actually, you'll find that for the DIM user table, you can actually depend on the ag events. So you can surface more information about events and endpoints in that dimension. It's still a relatively small 20 million per day. So now let's move into tenants. So now we want information about tenants. And we are going to get this from the source system. It's going to tell us information about the type of industry. Like if I want to slice and dice this by the type of industry people are on, the company size, other things, you can get it from this table. And we're going to do a similar approach where we're going to create we're going to structure the table. This is a dimensional table, really. And yeah, we're going to do it by snapshot. We're going to do change data capture. Every day, the source system is going to send to the data lake the differences, what changed in the database, and every day we're going to generate a new snapshot with the full history as of that day. Now, we have another tenant source here, and it's great, but we can do more with this. This is where the power of the modeling approach comes in. We could do something like this, where we can say, actually, what if I put usage information into the DIM tenant dimension? What if I, for example, say how many active users have there been? How many active users in the last 28 days? How many measures of like that? You can combine it into the DIM tenant table. And this also highlights another thing that I kind of skipped over, but we could have created a DIM tenant dimension earlier. Or we could have simply created it as a view. So a lot of times we have capability of creating certain things in the view. Given the relatively small scale of the DIM user table, particularly if you're only querying the last partition, we could do it on the fly and have a DIM tenant usage dimension. In any case, you can join these two, and now you have a more powerful DIM tenant table. But then we bring in subscriptions, and we do the same deal. And we now have a DIM subscriptions table. Well, guess what? We can extend DIM tenant with that as well. And we can keep adding and adding information. And we're going to do the same thing with users. So we're going to have users. We're going to create the DIM user source. and then we're going to join it, the source information with the usage information to have a much more expansive div user table. And this table is going to have everything, all of the properties plus all of the usage. And we're going to keep doing this. So the approach is we're going to have files. We bring the files into a single daily snapshot of files. This can get pretty big. In fact, you can already see this might approach 1 trillion rows because there's just a ton of files in the service. But it's still, with modern architecture and data lakes, this is still doable. You could also choose to use the approach of that I talked about earlier, where you just keep the last 30 days of partitions or whatever, so you keep the storage footprint small. We'll also do a little bit additional dimensions on top of this. What if we want to just have the dim file type per user? So that for every single user, I have file types. I've seen this firsthand. There's a lot of, it depends on how you define file types. You could have a lot of file extensions, as anything is allowed to be uploaded. But a recommended practice is to categorize, pick the top 30 or so, and then everything outside of that, put it in other. And you can evolve over time. But that would be a good way of keeping the cardinality of this low. But once we have dim file type per user, guess what? We can also extend the dim user table with dimension with that information. So not only do I have source and usage information, but I can have information. How many files? How many? What is the total storage footprint of each user of each tenant and things like that. In fact, I kind of hinted at it already, but we're going to do the same with tenants, and we're going to join here to the dim tenant table. So this is just a general idea of how you start building little by little, deviating from sort of the traditional Kimball approach. With this, one other thing before I open for questions is I've changed the user. We have multiple user dimensions. For example, we have 3 user dimensions and we have 2 tenant dimensions. You don't really need to have multiple ones. Those are internal tables, you could argue, and then just expose the ones that are not light blue. So you would end up something like this, where all of those tables, these are the actual tables you exposed, or it's the same that we have here, except with the gray and the light blue boxes. Everything else is what we expose to consumers. With that, yeah, I'm going to stop here for a second. I don't know if anybody has questions. I can't quite see the chat.
Joe, do you have a question?
Yeah, I'm curious, Jaime, if you guys have, and depending on what technology you're using, if you've messed around with materialized views at all, where the end user only gets access to one specific table, what looks relatively granular with a lot of columns. And when they issue queries, then it would obviously rewrite, push that down to different materialized views just to consolidate some of the entropy so that users don't have to know about 5 different tables. They can know about one. And then the optimizer, can kind of shuffle those queries around to hit different materialized views.
Interesting. That's a good question. I've never really seen that as a limit, or I've never heard or experienced this as a sort of, how can I phrase this? As I wouldn't say limitation, but as problematic exposing too many tables to them. So these are the tables that are exposed. And if you documenting well, if you have good naming convention, it's kind of obvious like what each are. You have the events. In the interest of making this fit in a slide, I don't have the full naming convention, but we tend to have like certain terms that define whether it's an aggregate, whether it's a dimension, or whether it's a fact table. So if that's available there, then, and you have a very consistent naming convention, you're gonna end up finding a couple of things. One, it's not like you're gonna have a lot less tables than I typically find in data teams that have like 5 different teams doing the user dimension. And so you have to, what's the difference between this user dimension and that? No, here there's a definitive one. And as you can see here, let's say the user dimension. There is one for the user itself. That's the grain of it. There's only one table there. If you want the user and the endpoint, or the user and the event, those are separate tables. So I guess what I'm trying to say is, as a consumer, and we end up using this heavily ourselves, we do a lot of analytics on it, which, by the way, is one of the things I encourage data teams to do. Because if you're not using the data yourself, how can you make sure you're building the right model? You're building and you're hoping that others are using. No, you have to like eat your own dog food. So we use it heavily, and this hasn't really been a concern for us, as it's quite well articulated the different things. But it's a, yeah, I don't know if that's, maybe others might have a different experience with that, but that's been mine.
Cool. Appreciate it.
So, Kirti, you have your hand raised.
Yeah, so typically in a dimension, you tend to store the attributes, right? So you have dim user, so you will store user name, user type, user class, user position, stuff like that, more information about user.
Mhm.
That's what makes it a dimension. What you are proposing here is really like accumulating snapshot facts, where at different date-based granularity, you're just accumulating the data, and every day, like you said, full outage and whatnot, you just keep accumulating. It's literally like a fact table, not a dimension. So I'm curious, why are you calling this a dimension?
Because, good question. So, and this is one of the biggest differences with Kimball, this conceptual one. And the first.
And sorry, just to tag on.
Yeah.
In this case, will we actually store all those attributes in all these three dimensions if these are really dimensions?
Yes, we will. Now,
Okay.
those three dimensions is, let's start with the basic one that you talked. Let's ignore everything and focus on dim user. Your point is, and this is the same point Kimball says, it should be about attributes. It shouldn't be about facts. That belongs in the fact table. So now he did agree on using bounded attributes, where you would say, let's say the simple fact is days active. Does that belong in the user dimension or not? Well, according to Kimball, you could put it there as long as you bounded it. And you said this is between 0 and 30 days active. So you're going to have like active level. And you're going to have a value that's going to be 0 to 30, 31 to 60, 61 to 90, more than a 90, let's say. And according to him, that does apply and does work. So to me, I guess the leap with the technology, I don't see a concern with extending that further and just putting days active. And there's two ways you interact with the user dimension. Either you just get the latest. Most use cases, you don't care about the history of it. You just get, in fact, we have a view exposing just one row per user. You go to the user dimension and you can easily say, well, I want to look at the engagement and the retention of users that have had at least 60 days of activity. They've been active at least 60 days. That is a filter, and you're filtering on that dimension. The dimension is user. So to me, conceptually, it still fits, even though it is a fact. It's a fact that describes the user. So it's an attribute of the user in that sense. Now, semantics, I hear you, and maybe some people will be against the fact that, well, it's not technically something about an attribute of the user, but to me it is. And I'll have a slide at the end, but Ramona, you might have something to add here, or a few other questions.
Oh, hi, Jaime. Well, I don't know that you're gonna like what I have to say.
No, this is why I'm here. I don't want to, yeah.
I already made my comment. I typed it while you're presenting. So I'll keep my comment agnostic, because that's how I like to speak. No dimension on facts, no that. So let's address first the business problem, because that's how you start. Without having a business problem to solve, you're not going to do any modeling. So So just looking at your presentation, right? I can do a reverse engineer from what I want at the end, and then reverse engineer it to how I want my model to go. And I, following database design principles, how the theory defined them, you can totally do this. So if I start on the way that you did, right, you start grouping by a large number of attributes, and then you keep aggregating on that. But that's just a principle of how grouping works. I'm sorry, Jaime, but maybe I don't have the experience of this level in industry, but I fail to see the novelty in this approach, because this is, to me, all common sense of how I did things and how I would approach it. So I don't know what I'm missing here, other than
I love the comment. A couple of things. It's not novel. It's not something I invented. This is widespread and used across a lot of large companies. So definitely not novel, and not something that I'm advocating that I've said. Like, there's this seminal paper by Maxim, the functional, I think it's called functional
dependencies,
data engineering, functional data engineering block, and he describes that. But he also didn't come up with that. It's something a common practice. So I just don't want to I don't want people to think that I'm saying that this is such a novelty. In fact, in essence, one of the things I like about this is how simple it is.
It's common sense, really. It's absolute to me, it's common sense. And without calling it anything, that's how I've been doing things. That's how I've been teaching students at university to solve. Not to this, to this level, but that is what we're teaching. And we just call it third normal form, not facts and dimensions, because that's what the theory says. So I find that if we get too sticky with terminology and too dogmatic, this is not something I'm telling you. I'm referencing Mr. Joe, who writes the book, right? We like, this is how we do things, and it's just a different name by a different, the same thing by a different name. So it's absolute common sense, and it has to start with the business problem we're trying to solve. And of course, here you are constrained by the cardinality of it all, and then you want to keep maintaining as much data down the pipe that you know that it will be relevant later on, right? So it touches to the point that the previous gentleman asked, and I think just calling it something, but do the procedure itself and the workflow is the same. It's just
completely, it's common sense. And I think the only highlighting here worth mentioning is that it deviates from the traditional theory of Kimball. And it's not that I'm against Kimball. Was a different time, but I just wanted to highlight this because I see a lot of practitioners trying to follow it in places that I consider not necessarily fits. Having said that, Rodrigo, I think, I'm sorry, I don't know who's next, but I saw Rodrigo's hand up.
Thanks, Jaime.
Thanks, Jaime, for presenting this. And just to reinforce what Ramona said previously, I think common sense is the least common of the senses, actually. And not surprisingly, we end up having lots of barriers with data engineers having this approach. Like starting with the data and going forward instead of coming from the business and going backwards, which I believe should be a great way to start. So I think what I'm missing here, because I think it's a great approach, it makes total sense to me, is having a methodology to map actually this data journey in a reverse way. Like, how do we start with the aggregated tables and going backwards to see how to ensemble all of this in order to make a good storytelling of how do we build this, how do we came up to this, but coming from the business and not from the data, like reversing the storyline, so to speak. But to achieve the same model.
Yeah. This is also going to get a little bit different, but as far as I'm concerned anyways, this is coming from the business in the sense of maybe not the traditional place that we're going to figure out all the questions that we have and we're going to work backwards. But in my experience, the business questions change every week. They change all the time. You have to build a flexible data model that allows you to build through concepts, not through the questions and what the business has. So this is an approach of trying to do that. In practice, I've seen this be quite flexible to adapt and change things. But I do take your comment about, well, is this always possible? Maybe there's certain industries regulated or very complicated businesses. This is a relatively simple business, and you're trying to do something in other more complicated ones. Maybe you need to pause and think more holistically. So yeah, that tension is something that I myself am always curious how to play, how to balance. And yeah, I can see that being a very different from the traditional data warehousing approach, that you spend a lot of time doing conceptual modeling and logical modeling, and you do this entirety thing. And I wonder, yeah, how do we balance those two things? But yeah.
It's a very minor change what I'm proposing. Like, instead of starting with the blue boxes, we maybe could start the storyline with the yellow ones, and then going backwards.
I see. Okay. Awesome. Thank you for that. I don't know who else is next. I'm sorry, Joe. Maybe you can help me with this as well. But Alexander, that's what is popping
up. Yeah.
Yeah, sure. Thanks. My question is a bit more in the retention period and partition section of the presentation. You mentioned sort of I guess maybe just for the sake of presentation, an arbitrary retention period of say 30 days worth of partitions. Do you have certain factors that play into how long you might make a retention period, or is it really just kind of driven by how much storage you're willing to pay for?
Good question. It definitely has to do a little bit with how much storage you're willing to pay for. If I have a table that is small, let's say, I don't know, small is relative, but let's say, I don't know, whatever definition of relatively small, and I can keep it for all time, why wouldn't I keep it for all time, right? So that's the first thing. Two is, like, there is a point where you have to like consider that cost, but I'm of the opinion that as much as possible, within reason, you should try to keep all the data. We're talking about like, and of course you have to have a valid reason for it. But I guess turning it around, what are the things, if you do not have that data, what questions you will not be able to answer? And something that I've encountered is, oh, we only have the last 2 years of data on this for a user. I'm like, well, and it's true, a lot of those users may be left, but there's a lot of insights that you can potentially mine from having a richer understanding of your user base. So you have to balance that a little bit. Unfortunately, it's not a simple solution, but I tend to prefer, I know I said 30 days. In practice, my position is keep forever, unless you have a good reason not to.
Yeah, and yeah, totally agree. And the use cases I look at are in cybersecurity. So when incidents happen, if they happen, you know, longer term storage for stuff that can help an investigation is always preferred. So yeah, we definitely want to hold on to stuff for longer than 30 days. Thank you.
Yeah, you're welcome. I don't know if there are additional questions.
Darmy, you have a question here.
So I don't have a question. I just want to say that I like everything you have said. When I was employed, I was actually with Nordstrom, and I was part of a group that used to review data producing teams and the events that they're creating. And we had this process and a structure for letting them think through what their data was going to do for the business. And I think I like what I see here, because it's like we had to sort of like force the business into sort of like a culture of thinking through all of that. And what I like about what I see here is that this is sort of like a functional function too in itself, right? It's like making business think, okay, what am I going to use this data for? Like, what would the users want to see? And you're already thinking about that for them, and sort of like modeling the data for them. And you're also testing it. I like the piece too where you mentioned dog footing. You're also sort of like looking at that data yourself to make sure that it makes sense to you. And I don't think a lot of people see that in like many companies. So I like that. I just wanted to commend that.
Thank you. Yeah, I want to tease up. I want to mention, I guess, double down on one important aspect of this, which is with this data modeling approach, and maybe it's not exclusive to this, but at least my sort of philosophy is try to always predict the questions that are coming in. Like you have to look at it as a business. What is the business about? What is the service about? What are the drivers of the business? And then put yourself in the shoes of anybody who's going to want to use this data to ask questions. So in practice, it's been interesting, but I think me and the teams that have been doing this data modeling, I'm not exaggerating with maybe 95% or more of the use cases we came up with without having to talk to users directly. Because a lot of these are pretty obvious, and they, like, if you really think about the business, these things flow naturally. So while it's great to talk to stakeholders, and you should, I encourage you to do that, you don't need to. You should be of the mindset of, I want to predict what people, and it's kind of hard, and it's hard to do in practice, but the more you do it, the more you realize that you can go pretty far by just thinking ahead. Do we have any other questions? Well, we're almost done.
There's one in the comments here from Dennis. I don't know, Dennis, if you just want to vocalize your question, if you're able to. Or I can just read it out. Dennis asks, given the flexibility of your data model, at what point does it become agile enough where you have to move away to give to another, I'm guessing another data model, given that the current one doesn't fit your needs? So I think the question is more about agility.
Yeah, it's interesting. With this approach, I have yet to see this not scale or move in a direction that, or have us have to move in a different direction because we didn't think about this thoughtfully. So this, to me, what I really like is you can always extend, you always have new sources, you all have new ideas. And in practice, I haven't ever met limits to this. You can kind of work around the edges, you can improve. All the time we keep improving new columns, adding new columns, new tables. Sometimes, very rarely, we break schemas, and I don't like that, but sometimes we have to do it for a good reason. But you can get a lot of it by just either new tables or extending fields. That's one of the things I like about this approach. The one thing, if we have a little bit of time, this might be the other very controversial thing, but those who know me, I love controversies. I'm going to skip ahead, and I'm going to show this as a summary. And I say this outdated with a quick, little star asterisk, because it still makes sense for certain use cases, but I kind of have the differences with the Kimball approach, the traditional theory of Kimball, and sort of the way that I've been modeling data. And we have these different principles. The 5 ones are SCD type 2. What was the original rationale and why it no longer applies, in my opinion, for cases like this. Same thing with fast changing attributes, surrogate keys. The aggregate facts tables should not be exposed to analysts. And I think the one that came up in this one was the fact versus dimensions. Like, you should keep facts in facts and dimensions are separate. And I think I understand the reasons for that, but I think in the modern era, they no longer apply, or at least in the use cases that I described, analytical, where you have a lot of data, or you might have a lot of data. And cases like this, I am of the opinion that they know, but I'll let this sit for a little while. I don't know if this prompts others. But happy to also go back to any other part of the presentation.
I'm waiting for the person with the violent aversion to. Yeah, it is interesting, right? I mean, if I'm looking at actually this book here, I think in this edition, especially, it's fascinating because
I have it as well. I like I love Kimball. Just
It's good. I definitely I think it works well until it doesn't, right? And so I think there's a variety of reasons. I think what I've seen is if your data gets to a certain point of scale or velocity or complexity, it's almost like you're trying to shoehorn in an orthodoxy, I think unnecessarily. And there are probably better approaches to it. What's funny is this one, it came out around, I think this edition's discusses the big data era, because that was starting to come up. And so it was like, well, you can still, yes, it's being recorded, John. So you can still, so it was almost like they were playing defense in some of the later editions of this book, where they're like, well, you can still use it. But as you point out, storage and compute, I mean, it does, you know, we always want to say that the Kimball is kind of more of a logical data model, but at the end of the day, the physical does matter. So,
and to be fair, I don't want this to come as a critique of Kimball itself, because it started in the 90s, early 90s. He sure had multiple editions. I believe the last one is in 2000, early 2007, 6, I don't know. He did mention big data. He mentioned what is it? Schema on read, which I've always considered that an anti-pattern, but that's fine. But when the book came out and the principles he had were really important with the limitations and the requirements of the era. So it's not a fault of Kimball. It's rather like we haven't had anybody of his stature in this new era come up and sort of tell us new ways of doing it. And when it's the only book out there, it sometimes makes it hard for new practitioners because they think they have to follow it the same way. Which part of, I guess, my message is this, is also not be dogmatic. Even in this approach that I'm suggesting, it only makes sense in certain use cases, and you have to be flexible and adopt what makes sense and what doesn't. And I think it's more, not Kimball it's himself, but more of how the field or in general views it that it's problematic.
Yeah, I agree. It's interesting because if you go back to the early discussions on all this too, like it was, in fact, it was funny tidbit too, is Mark Demarest actually came up with the idea of the star schema. It wasn't Kimball. It predates Kimball by about 2 years. I thought that was pretty fascinating. But the notion really was, the arguments back then was whether, you know, normalization or denormalization. That was the argument of whether you want to go with total normalization with the COD, you know, suggestion or Kimball. But you're absolutely right. The discussion really hasn't progressed since then, and from what I've seen, like it's very much like do it Kimball or figure out like one big table was the other one, where there's sort of almost the allergic reaction to Kimball in some weird ways. So, but I like what you're doing, where it is kind of Kimball-ish, but it fits your purpose, because I think your purpose is a bit different, you know, and nothing wrong with that. So,
yeah, and I think in the case of OBT or one big table, like I do see it as you can build OBT at top of this as the last layer for maybe certain reporting needs. That's fine. But what I've seen misused is people just do OBT as a modeling replacement of this, and that's where I think it doesn't scale or work.
Yeah, absolutely. Cool. I know we're at time. Thanks everybody for showing up. I mean, much appreciated for this one. Yeah, it's great. So. We are not taking questions anymore. I'm sorry if you raised your hand. So yeah, again, much appreciated. Next week we have Jamie Davidson actually from Omni is going to be presenting. They're doing some really cool stuff in the BI space, and so I think if you're interested in that, I'd say look forward to the promotion on that. I will stop recording and let you all get on with your day. Yep. Much appreciated.
And we're all in the Discord channel, so any